Hello everyone, good evening and hope you all are doing good. So myself Rajat Mishra, the Chief Trainer of Skyy Institute and the trainer of two-wheeler and EV vehicles. So today's topic is electric vehicles, the future mobility. Before going on to today's topic, let me tell you about a bit about Skyy. Okay, so Skyy Institute is a skill training institute which impart knowledge on different 100 plus courses. So our courses are basically industry related. So today, the same kind of workshop we have brought on you, that is electric vehicles, the future mobility. So the demand for electric vehicles in today's time is increasing because the shortage of the fossil fuel and the increase in the global warming is alarming and it is very critical. So today's demand for electric vehicle is so much that all the governments of world are trying to convert the vehicles from IC engine to electric vehicles. Okay, so stay tuned in this program if you want to learn about the electric vehicles. So the future mobility, why we say the electric vehicle, the future mobility? Because in the future, we want a power source which is not only eco-friendly, but it can be available to everyone. In today's day, electricity is a major requirement to every citizen of the world. Every citizen is viable to your electricity. So if the power source is electric, then every person on this earth can afford a vehicle. Okay, so let's start today's topic, which is electric vehicle, the future mobility. So the past, were the vehicles of the past. So before going into the electric vehicles, let's discuss what were the vehicles of the past. You can see in 1769, the first vehicle, the first running automobile was made, which was made by a French inventor, Nicolas Cognot. So he invented a three-wheeler vehicle which run by steam power. Okay, so the power source of this vehicle was steam. It was the last three-wheeled vehicle that moved at the speed of a walk and was meant to haul cannon. So this was the first time when the mankind saw an automobile moving. Okay, so it was a steam-powered vehicle. You can see there is a boiler at the front. So this boiler produced steam, and because of that steam, the turbines or the motors were powered. Then the Carl Benz in 1885, German mechanical engineer Carl Benz designed and built the world's first practical automobile to be powered by an internal combustion engine. So he was the first person to make a vehicle of gasoline or an internal combustion engine. The vehicle that I showed you before, it was an external combustion engine. The combustion took place outside. But Carl Benz was the first person who made an internal combustion engine. Okay, so it was his development that now we can use IC engine and can run on it. Scotsman Robert Anderson is credited with inventing the first electric car sometime between 1832 and 1839. You heard it right. The electric vehicle concept was made long before the IC engine evolved. Okay. So the first electric vehicle was made by Scotsman Robert Anderson. So it was made in 1832 to 1839, long before Carl Benz made a IC engine. So why did this concept flop? Why did this concept didn't rise? The reason of that is the fossil fuel availability at that time was huge. So no one thought of using any alternative source rather than your fossil fuel. Okay, so the electric vehicle segment dropped at that time, and the IC engine, the gasoline engine concept was raised, and all throughout these years we've been using the IC engines. Now the present. That was about the past. What is the present? In the present, we are making vehicles which are of the topmost technology. For example, Jaguar has launched Land Rover. So this vehicle is using test projects and several technologies which are ahead of its time. Jaguar is working on several test projects to create a connected and autonomous vehicle. So what is connected and autonomous vehicle? Connected and autonomous vehicle means the vehicle can interact with each other. Okay, so with this interaction, now driverless cars we are making. We are trying to make driverless cars where there will be no drivers. SSC Toyota. So it is a turning point in the development of fast cars. On October 19, SSC sent out data and announcement that the Toyota had achieved 316.11 miles per hour. That is close to 508 kilometers per hour. The speed we cannot even imagine. In India, we see a top speed of 200, 300, but this vehicle, SSC Toyota, achieved the top speed of 508 kilometers per hour. So in present now, we are making vehicles which has crossed the limit of technology. Also, we have crossed the limit of speed. So what is needed? We need electric vehicles. Why? An electric vehicle is a vehicle that uses one or more electric motor for propulsion. So basically, our electric vehicles are something which changes the power source of the vehicle. Here, we don't use the fossil fuel which will be over one day. We are using electric motor which run by electricity, and electricity can be generated by all the renewable sources of energy. An electric vehicle may be powered through a collector system by electricity from our vehicle sources, or may be self-contained with a battery, solar panel, fuel cells, or an electric generator to convert fuel to electricity. So a electric vehicle can be made of any system, like it can be made of a self-contained with a battery. We can put a battery in the system, or it can be made of solar panels, fuel cells, or an electric generator which will convert the fuel into your power source of electricity. Okay, so this electric vehicle has a lot of options and lot of methods for implementing the power source. Back to the 1990s, in the 20 years since the long gas lines of 1970s, interest in electric vehicle had almost died out. So what happens in the 1970s to 1990s, it was a time when the fuel power or the fossil power was at its peak. So all world used the fossil fuel as the alternative. They didn't think about the electric vehicle. We didn't have any idea about the electric vehicle. But the new federal and state regulation began to change. The passage of the 1990 Clear Act Amendment and the 1992 Energy Policy Act, plus new transportation emission regulation issued by the government board, helped create a renewed interest in electric vehicles. So what happened due to the regulation changed by the government, we developed electric vehicles. So government has a major role in playing for developing the electric vehicles, because the government has brought the transportation norms and the air act norm by which the pollution has to be decreased. So due to this only, your electric vehicles were developed. The first electric vehicle which was developed is developed by your General Motors EV1. It was the first electric vehicle which was developed in approximately 1996. Okay, so it was the first electric vehicle that was developed at that time. With progressive time, the technology of EV has developed, and the world today is observing electric vehicles which are better than the IC engine in terms of performance, speed, and technology. So as we progress from 1996 to 2021, we have seen a lot of change in the electric vehicle sector. The world today is progressing, and the progress is unbelievable. Companies like Porsche has made vehicles like Porsche Taycan. It is one of the best class electric vehicles that you can avail in the market. There is also Tesla Model S Plaid, which provides mind-blowing mileage and fuel efficiency. We also have the BMW i4 series, which is developing world-class products with all new technology and creating an environment for autonomous vehicle communication. So these are some of the vehicles which are topping the list of the electric vehicle segment. these three vehicles that I showed you, these are some examples of how the electric vehicle segments can have a brighter future, and they are still doing miracles in the term of transportation. Now let's talk about the growth of electric vehicle. How we can see the growth of electric vehicle. The key component of an electric car. So what are the key components we have for an electric vehicle? They are battery, charging port, charger, a DC-DC converter, power electronics controller, regenerative braking, and drive system. So if all systems are there in an electric vehicle, then this vehicle we can call an electric vehicle. So first see, the purpose of the electric motor is that we utilize the electrical energy stored in batteries for powering the electric vehicles. So this electric motor, which is the replacement for the engine, it utilizes the power from the battery and provide that power to the powertrain. The EVs become environment friendly as they are recharged with lower emission power sources. The primary function of the battery is to provide power to the electric car for making it running condition. Generally, EVs use lithium-ion batteries. So today, the batteries that the EV use is lithium-ion batteries because they are more efficient than other cells due to their lightweight and negligible maintenance. So two reasons for using your lithium-ion cells are they are lightweight and negligible maintenance. The maintenance is very low. The manufacturing of these batteries is a bit expensive as compared to the nickel metal hydride or lead acid battery. The problem in this facility of making your lithium-ion battery is the manufacturing process. The manufacturing process is costly, so that's why the system or the battery cost is more. Okay, so lithium-ion battery is a bit expensive as compared to the nickel metal hydride and lead acid battery. Depending upon the climate condition and location, the maintenance schedule, the lithium-ion battery lasts up to 8 to 12 years. So the largest lifespan of the battery you can find in lithium-ion battery. Lithium-ion battery has the largest lifespan. It can last up to 8 to 12 years. The charging port in the point that permits the vehicle to connect with an external power supply system through a charger to charge the battery. So charger point or charging point is a unit where the vehicle can connect to a charger. The function of the charger is to take AC supply from the powerhouse using a charge port and convert it into DC power for charging the battery. So the charge port that is used or the charger which is used, there are three types of charger actually. Once we use a fast charger which can charge your vehicle with a full efficiency in a half an hour or 1 hour. Then we have two types of voltage supply at our homes, 120 volt or 220 volt. In a 220 volt, your vehicle will take 4 to 5 hours. In a 120 volt, your vehicle will take 7 to 8 hours. So according to the charger, your vehicle will charge the battery according to. The DC-DC converter converts high voltage DC from the battery to low voltage DC power to run the vehicle accessories. Then also we use a DC-DC converter, direct current to direct current converter. See what happens, there are many instruments which are there in the vehicle which does not need high amount of voltage. Okay, like your lights, your horns, your regulators, they need a lesser voltage. So we have a DC to DC converter. Okay, so this DC to DC converter converts the high voltage to low voltage and supply it to the system. The regenerative braking plays an essential role in maintaining vehicle strength and achieving improved energy. The main component of an electric vehicle is the regenerative braking. Due to this regenerative braking, your vehicle can have vehicle strength and also achieve improved energy. This braking method uses the mechanical energy from the motor and converts kinetic energy into electrical energy to give back to the battery. So this regenerative braking system, what it does, it converts the kinetic energy to electrical energy and give back to the system. So with the help of this, the battery life can be increased. And the role of the drive system is to generate motion by transferring the mechanical energy into the traction wheel. So the transmission of the drive system which is used, its main work is to transfer the power that it is getting from the motor to the traction wheels. So types of electric vehicles. What are the different types of electric vehicles? So the first type of electric vehicle is a hybrid electric vehicle. A hybrid electric vehicle consists of IC engine and electric motor. Here the batteries get charged by the engine by the energy generated by deaccelerating and braking. In the current scenario, they are referred to as hybrid vehicles because they combine a combustion engine and an electric motor as a power source. So basically, a hybrid electric vehicle is one where we have both. We have a IC engine also, we have a electrical motor also. So you can see in this flow chart, the battery gives the power to the converter, converter gives it to the electric motor. Electric motor power is going to the transmission, then from transmission it is going to drive. Your internal combustion engine, which is running by fuel, it is also giving power to the transmission. So we can switch over. Either we want the battery power from the electric or we want the fuel power from the IC. Okay, so as we can use both the system to convey power to the wheels, it is called as hybrid electric vehicle. The second type of EVs that we have is plug-in hybrid electric vehicles. So this plug-in hybrid electric vehicles comprise of an internal combustion engine and an electric motor. These vehicles are powered by gasoline and have a large rechargeable battery which is charged up with electricity. So basically the difference between the plug-in hybrid and a hybrid is, in the plug-in hybrid we have a large capacity of battery storage. Okay, so battery storage capacity is high and the vehicle can only run by your battery power. But in a hybrid electricity vehicle, your vehicle cannot run by only battery power. Then we have the battery electric vehicles. So this battery electric vehicles, also termed as BEV, is fully electric vehicles. It has no gasoline engine but consists of high capacity rechargeable battery packs that can be charged from an external source. Okay, so this battery electric vehicles, they are purely electric vehicles. They don't have any IC engine, you don't have any fuel there. They are purely run by your electric motors. Okay, so we have a battery here, the batteries get charged by some source, and with the help of the power of the battery only, the electric vehicle is run. So let me give you a comparison between an electric vehicle and a hybrid. So according to the CO2 emission, that is the carbon dioxide emission, electric vehicle has very low electric emission and a hybrid vehicle medium. That means 50 to 60% of internal combustion engine. Price range. The electric vehicles are very costly, the price range is high, whereas the hybrid vehicles similar to internal combustion engine. The price range is very similar to the internal combustion engine. Then comes the fuel use. Fuel means gasoline. So in case of electric vehicle, none. We don't have any fuel uses. But in hybrid vehicle, we use 40 to 60% of internal combustion engine. That means 40 to 60% use of your fuel is done by the internal combustion engine. Charging. So electric vehicle require charging, hybrid vehicle does not require charging. Because by the running of the engine only, the battery can charge. Okay, so that's why the charging is not required in a hybrid vehicle, where the charging is compulsory in an electric vehicle. EQUPMENT charging facility in India. So the electric charging facility for electric vehicle is very low, whereas the hybrid vehicle potential is very high because it can run by both fossil fuel as well as electric energy. Powered by electric engine, whereas the hybrid vehicle is powered by internal combustion engine and electric engine. Okay, so this electric vehicle is only powered by your electric engine, whereas hybrid vehicle is powered by both your IC engine as well as engine electric engine. Okay, so this is the difference between electric vehicle and hybrid vehicle. So in terms of affordability, electric vehicle is a slight difficult to afford, but in terms of environment friendly and uses, the electric vehicle is at number one. Okay, so this is a very critical thing. A electric vehicle, the most important thing is battery. So in the coming days, we have to improve our battery technology if we are to improve the electric vehicle sector. So battery thermal management system is something which is very important. The use of EV will increase in near future, and so priority is given to the need of developing effective batteries. The thermal degradation of the battery is a big challenge for every BTMS, which affect the range of the EV. The main objective of the BTMS is to control the temperature of the battery cell and thus improve the battery life. Okay, so battery thermal management system. That means when the batteries are continuously running, it produces heat. So that heat has to be effectively taken out from the environment or from the system. So this battery thermal management system or the BTMS, what it does, it effectively transfers the heat from the battery to another source, or it cools down the battery. Okay, so this system is developing day by day so that maximum efficiency we can get from the battery system. Hybridization factor. Now, what is this hybridization factor? The vehicle can also be classified depending upon their hybridization factor. The hybridization of vehicle helps in improving the mileage, generally communicated as miles per gallon or miles per gallon gasoline equivalent. MPGE can be utilized for plug-in hybrid electric vehicles where 33.7 kilowatt hour electric energy is the equivalent to the energy of 1 gallon of gasoline. See, 33.7 kilowatt electric energy is equivalent to 1 gallon of gasoline. Okay, you can see the huge difference. So how to take out the hybridization factor? So hybridization factor is PEM divided by PEM plus PIC. So where PEM is the total power from electric motor. Sorry. PEM is the total power from electric motor and PIC is the total power from internal combustion engine. So when we sum up the total power from electric motor and total power from IC engine and divided by the power output of the electric motor, then we get the hybridization factor. So this hybridization factor tells us how much dependable the vehicle is on the electric energy and on the IC. Okay. So every hybrid vehicle which is made, which is used, use this hybridization factor to know how much the dependability is on the electric motor and how much the dependability is on the IC engine. Now, for promoting the EV vehicles, for promoting your EV segment, the government has launched different schemes. The government also warned that every people should buy electric vehicles. Now let us see some schemes which are launched by the electric vehicles in India. Central government and state government have launched various schemes and incentives to promote electric mobility in India. National Electricity Mobility Mission (NEMMP) declared by the Government of India to enhance the national energy security, mitigating the harmful effect of fossil fuel powered vehicles on the environment and development of domestic manufacturing capabilities. So this NEMMP has declared to enhance the national energy security. So as with the help of this, they will scale 6 to 7 million units of electric vehicles, which in turn would able to save 2.2 to 2.5 million tons of fossil fuel. So the planning for this NEMMP is that they will increase the sale of electric vehicles by 6 to 7 million units so that 2.2 million tons of fossil fuel can be saved. See, fossil fuel, once it is erased, we are not going to get it. Okay, so it is very important for us to save the fossil fuel. So day by day, we are searching for new means of power, new means of technology. So by using this electric vehicles, we can decrease the use of fossil fuel in the automobile market. So we can save about 2.5 million tons of fossil fuel by using 6 to 7 million units of electric vehicles. The government of India has launched a plan on faster adaptation and manufacturing of electric vehicles, which is named as FAME 2, to empower quicker adaptation of an electric and hybrid vehicle. This scheme also encourages purchase of EVs by providing various incentives and setting up of charging infrastructure. Now, the government has done a very good initiative. What they did, if you are buying an electric vehicle, okay, they are providing you subsidy, approximately 10,000 subsidy. So if you're buying an electric vehicle under the FAME 2 Act, you will get a subsidy of minimum 10,000. So this system is done to encourage individuals to buy electric vehicles. The Society of Indian Automobiles, SIAM, along with other automobile manufacturers, aim in achieving selling of 100% pure EVs for intercity public transport fleets by 2030. So the SIAM is concerned about the transportation sector. Okay, so they are concerned that the transportation sector, the trucks, buses are a very huge area where the fossil fuel are most used. So this sector will be totally changed by 2030. All the buses, all the trucks that you see will be converted to EV. Okay, so with the use of this, the saving on the fossil fuel and the saving of the environment will be very large. Now, barriers for the EVs in Indian market. So, if a technology has been introduced, there are some barriers which are there in this market which block the users of this technology. So, let us see some barriers in the EV market. Barriers for the EVs in the Indian market can be addressed from various perspectives such as technical barrier, policy barrier, and lack of infrastructure. So let us see what are the barriers which concern the Indian market. So first we will go to the market condition. First is vehicle service. Now the electric vehicle segment is not so dominant. So the servicing setup and the trained technicians, trained engineers for this are not available. So that is the problem. The vehicle servicing setup is not proper. So if the EVs are launched in a good amount today, then we will not get a proper market for servicing or for maintaining the vehicle. High capital cost. The initial cost of the vehicles are high, which leads to many buyers, because most of the Indians buyers, it is a necessity of two-wheelers, four-wheelers. This is a necessity now. So as the initial cost is high, many people don't go for the EV alternative. Consumer perception. Now this plays a very important role. Still now, many people think that EVs are not successful. They will face a lot of problems. The charge can get over. They will not give proper power. So the consumer perception towards the EV is not good, which has to be changed day by day. Raw materials for batteries. See, the raw material for batteries which are used like lithium, iron, cobalt, phosphate, these are very rare earth materials. Okay, so these are very rare to find. So manufacturing cost also increase, and also the availability is very rare. So that's why the raw material availability is a big question. Let me go on the technical barriers. Efficiency of batteries. As I told you before, the efficiency of batteries is a major sector where we have to work. We as engineers have to develop new battery technology so as to meet the targeting sector of the EVs. Okay, drive range of electric vehicles. Now this has been improved. The drive range of electric vehicles have been improving day by day. Now there are vehicles which can travel 500 kilometers, 1000 kilometers in a single charge. So this is changing. Day by day, the drive kilometer or the drive range is increasing. Charging time. Now this is something which is happening everywhere. If I am taking a vehicle and at the middle of the road my charge gets over, and there is a charging setup also. So it will take 3 to 4 hours to charge. So should I wait for 3 to 4 hours? Not logically true. So the charging setup should be set so that fast charging will be available at every point. So with the help of this fast charging, what will happen? The fast charging technique will evolve, and within half an hour, your battery will be fully charged. Safety. Now, safety is a major concern when we think about electric vehicles. Some may think that the electric vehicles may go burn, the electrical wires may short circuit may happen. So something like this may happen. So safety is a major issue which are there in the consumer mind. Environmental impact. So as we know, EV's environmental impact is low, but the manufacturing cost of the EVs, the battery settlement cost. So in this process, the emission is more. There is 30 to 40% emission in the battery manufacturing, in the vehicle manufacturing. So this also has to be decreased so as to increase the efficiency and emit the greenhouse gases from the environment. Policies, electricity tariff policy. Now the government has given so many policies to increase the sales of EV vehicles, but these policies has to be improved. The vehicle rate has to come down so that it will be affordable to any person who is moving on this earth, whether it be a poor person or whether it be a rich person. Infrastructure, charging infrastructure and battery recycling. These two are a major disadvantage that we are facing. Charging infrastructure. At every point of India, we can avail an EV. We can avail an electric vehicle. But the charging infrastructure you will not avail at every point of India. Any few cities in India only have good charging infrastructure, like naming a few: Bangalore, Delhi, Bombay. So these are few cities which are having good charging infrastructure. But the charging infrastructure has to lead and it has to grow so as to improve the quality and so as to improve the consumer retardedness towards the vehicle. Okay, so consumers should feel safe. He should feel that everywhere there is a charging setup, so I can take this vehicle and I can easily move around with it. Next is battery recycling. See, in India, if we talk about battery recycling is very rare in India. We throw the batteries with the regular garbage and they disposed of in the regular dustbin. But these batteries have critical materials like lithium, phosphate, iron, cobalt. So these are rare metals. So the recycling of the batteries is very important. Okay, so if the proper recycling market is there, the batteries can be recycled and these metals can be used to make new batteries. Okay, so these are the two infrastructure barriers that we are facing. So these were some of the barriers according to the market, technically, policy-wise, and infrastructure. Okay, so let us see something about the battery recycling. Battery recycling is a recycling activity that aims to reduce the number of batteries being disposed as municipal solid waste. Batteries contain a number of heavy metals and toxic chemicals, and disposing of them by the same process as regular household waste has raised concern over soil contamination and water pollution. See, as these batteries have rare earth metals, so when they combine with water or when they combine with land, they make the land unfertile and make the water polluted. India is one of the world's chief consumer of lead acid batteries, according to the India Lead Zinc Development Association. So India is one of the world's leading consumer of your lead acid batteries. India lacks a formal plant recycling industry. The industry is not respected and lacks designated zones for recycling. So in India, we don't have any recycling industry. Okay, there are very less recycling industries which are of the small scale. But in a large scale setup, we don't have any battery recycling industry. Two of India's largest lead companies, Gravity India and lead battery manufacturer Amara Raja, partnered to annually recycle 8,000 tons of lead scrap. The company said the joint program is to advance environment protection and sustainability. So these two companies, they joint venture with each other to make 8,000 tons of lead scrap every year. 8,000 tons. The two companies. If there are more companies, we can increase this number. So with the battery recycling, we can reduce the cost of battery manufacturing. So once the recycling process is set, the battery manufacturing process and the battery manufacturing cost can be reduced. So this is one of the ways by which we can reduce the battery manufacturing cost. So major concern for IC vehicles or internal combustion engines were carbon emission. The carbon emission were low, and this emission resulted in greenhouse gases, which resulted in global warming. Today, the glaciers are being watered down. The glaciers are breaking. It is just so hot. If you are not knowing, July 2021 was the hottest year till the earth has faced till now. It was the hottest year of the century. So, day by day, the temperature is increasing and we are doing nothing about it. But we should be concerned about it and we should do something. So, shifting to electric vehicles is one of the initiatives that we can take. So, you can see in this chart that these are the different statistics of different countries like Europe, United States, China, and India. So you can see that ICEV, it is internal combustion engine vehicle, and BEV, that is battery electric vehicles. So you can see the difference in the consumption and power and the pollution in both the things. So in the case of ICEV, the consumption of power and the maintenance is very high. But in case of BEV, that is battery electric vehicles, this consumption of power and the resultants of pollutants is very low. So due to this factor, all the major industries and all the major countries are shifting to electric. India is nowhere behind. India has planned so many schemes like the FAME2. It is one of the schemes to innovate and to motivate the users of the vehicles to buy electric vehicles. So there are so many companies. Tata has launched 2 to 3 models of electric. Mahindra has launched a model of electric. Wagoner is coming electric. So every company, every car manufacturing company is going electric. So the EV industry is just at its start. It is the starting phase of the EV industry in India. And the possibility and the growth we cannot imagine. After 10 years, in 2030, this industry is growing so big that it is growing by a percentage of 35% per year. In the previous year, if the sale was 2,000, this year it will be 35%. So it is growing by a compound annual growth of 25 to 35%. So carbon emission control is a major concern in our environmental practice. So due to this reason only, the EVs have been adopted and it is used world over. So market growth. So how the market is growing in the EV sector? Indian electric vehicle supply equipment market is increasing day by day. If you can see in 2019, the market size was $1,027 thousand, whereas in 2025 it is estimated that the market size will be $13,833. Market growth rate is 54.2%. So 54.2%, that's an unbelievable growth of the market. So today, I say now is the correct time when you should try your future in the EV industry. So if you see the Asia Pacific, the BEV vehicles, that is the battery electric vehicle sales have been increased. So the sales that were doing in the previous years, now it is increasing day by day. So the sales of the battery electric vehicles are exponentially increasing with compounding growth. Now let's talk about the benefits of electric vehicles. What are the benefits of electric vehicles? Cheaper to run. It is cheaper. It will cost you around 10 rupees a day for the charging. cheaper to maintain. There are no maintenance costs because engine there are more number of moving parts. But here only electric motor is the part of the system, so cheaper to maintain, cheaper to register. Now the government has done registration free or provided some concessions on the registration. So the registration of your EV vehicles is very easy. Better for the environment in two factors: less pollution, renewable energy. So the EVs produce very less pollution and also renewable energy. Electricity can be produced by any renewable form of energy. So that's why no use of the earth material will be there, and we can use the electricity power from any renewable source of energy. Better for our health. See, today the world has grown so dramatic change of carbon is there that in Delhi we can see the pollutant content is so much that in few years you have to use mask in a regular basis. So if you want to decrease the pollution, there should be number of trees more, the water should be less polluted, and also the air should be less polluted. So how you can decrease the air pollution? By using the electric vehicles. Fossil fuels from automotive, the emission from fossil fuels from automotive is a major factor which contribute in the environmental condition. So if we decrease the use of IC vehicles and increase the use of EV, then our health will be also better. See, before 100 years, the minimum age of living was 89, but now the minimum age of average age of living is 67. So 20 years gap means your lifespan is decreasing by 20 years. That's a very huge concern. Better for the network. Networking between the system is easier in electric vehicles than in the IC vehicles. Better for our energy security. See, if we produce more EV vehicles, then what happens? What we can do? We can save our fossil fuel. We can use the fossil fuel for different areas and we can save it. So that in emergency condition, we have stored fossil fuel and now we don't have to buy fossil fuel from different countries. We were buying fossil fuel from different countries. But if we have our own electric vehicle setup, we don't have to buy fossil fuel from any other countries. Career growth in EV market. So this is what you are concerned about. Now you are a student or of engineering person. So now you would be thinking, what job should I do? Which industry should I join? So if one industry is there in which you can join and which has tremendous progress is the EV sector. EV is an industry which is growing at a tremendous rate. The compound annual growth is 34.5%. In 2017, it was a 71.1 million industry, but in 2025, it is approximately 707.4 billion industry. Okay, so this huge gap, this increase in the industry is what you can be a part of. So the career growth in EV market is very huge. So proper training in the EV segment and proper knowledge of the automotive and EV segment is very necessary for your growth in the EV segment. So we have come to the end of our slide, but for the last I want to say you that electric vehicles are the future mobility. The industry which are coming forward, the industry which are going to come, the automotive industry is changing at a dramatic rate. Now the sales of the regular motorcycles, the vehicles, the cars is decreasing and the EV sales are increasing. So within 2030, if you are now a fresher, if you are joining the EV industry now, within 2030, your growth will be exponential because this industry is growing. Now the vehicle which is coming at 1 lakh, it will be 60,000. So the affordability will increase and your value will be increased. So students, today is the time when you should take a decision. today is the time when you should inherit a skill. Today is the time when you should go for your career growth. So at Skyrider, we preach one thing: skill is everything. So if you want to be skilled in the EV segment, we have a lot of courses and also our electric vehicle courses which are designed specifically to empower you on your electric vehicle segment. Okay, so these courses are specially designed so that you know each and every system of the electric vehicles. So at last we come to the end of the session. So now I hand over the session to Himanshu sir. Sir, are you there?
Just give me a second.